Welcome to the micro communication course. Today we talk about that a E-plane T or a E-plane junction there. Now we will derive there a S matrix for the E-plane T. Now you see here, so that E-plane T here, we have the a third port here. We're supposed to talk about this third port here. Okay, so this is about your E-plane T. Now for this E-plane T, another port is a parallel to this electric field component. Now this one is about a electric field component here. This one is about a E here. Now we have the another arm. That arm is a parallel. That is how the arm that would be parallel. Okay. Now this one we can say that, and this arm is called as a E arm. This arm is called as a E arm here. So this we can say that a port one here. This one is about a port two here, and this one we say that a port three. Now the properties for this E plane T both are the same here. So now we say that earlier. So it has a three port there. So then that S matrix for this E plane T will be a 3 by 3 matrix since it has a three port here. Means you can say that AS matrix is about a 3 by 3 port here. And then we see here how your electric field component is propagating through this. So and generally this E plane T is called as a series arm. Okay, so you can say that we say here for this E plane T a series arm, because this arm is looks like a series here, so that's why it is called as a series arm. Or again, we can say that this particular junction is called as a voltage junction. Okay, this is called as a voltage junction here, or a series junction, or we can say that voltage junction, or we can say that a series junction for this particular E arm here. The main waveguide is about a port one and port two, and then another port is there. That that port or this particular arm is present in an E plane, so that's why it is called as a E plane. This particular structure is called as a E plane, and we say that a port 3, this port 3, it is perfectly matched to the given junction. Port 3 is perfectly matched to the given junction, so that's why here we can say that a port 1 and a port 2 are electrically, port 1 and port 2 are electrically antisymmetrical, electrically antisymmetrical with port 3. Okay, with port 3. So this one is about, we can say that this particular junction, that port 1 and port 2, both are electrically antisymmetrical with respect to the port 3. But the condition is that that collinear arm, with this particular arm from this given junction, both are the equal here. That both are same there. In that case, that port 1 and port 2 are electrically antisymmetrical with respect to the port 3. Now then we can consider that for a given particular E plane T, how you give the, how you excite this particular T here. So now for example, I say here for your E plane T now, I suppose to consider this one is about a E plane T. Now I suppose to be draw a waveguide now. Okay. So now for this particular, this one is about your rectangular waveguide now. And for this given rectangular waveguide, supposed to be draw big one. Now for this rectangular waveguide, we're supposed to say that there is a arm, that arm is a parallel here. Now this one is about arm. This one we can say that the arm is a parallel one. So we can say that this one is about your structure. I say that this one is about your E plane. Okay, this is about your E arm now. So now if supposed to be I say that a electric field component are propagating from this port 3, it is entering now. So how your field components are looks like? The full components are, we say that in a port, likewise in one port the direction of this field components will be likewise, and in another port it will be a likewise. So as we say that port 1 and port 2 are electrically antisymmetrical, but the magnitude is same. Okay, but you can say that it is about the antisymmetrical there. Then consider that for a given particular E plane T, so the symbol for the E plane T is how, what is the symbol for the E plane T? This one is about a port 1, a port 2, and this one is about a port 3. This one is about a symbol for the E plane T. And if you wanted to draw a equivalent for this, then we say that port 1, one is about a port 2 here, and this one is about a port 3 here. That is about the equivalent for this E plane T. Now, through this, now we'll conclude about what are the S matrix component or S parameter component for this E plane T now. Now say, we say here, if we consider that this is about a port 3 now. Now if a amplitude input, if we apply the amplitude input of A here at port 3 now. If we apply the amplitude input at port A now, okay, if port 3 is the input and we are applying that amplitude is of A here, then what happen? We'll get the output at a port 1. Okay, we will get the output at port 1 and a 2 here. That output at a port 1 and a port 2, that will be what? A by root. Okay, output will be at A by root 2 there. Because we can say that here, that amplitude, we just talk about the amplitude. Amplitude is equally divided here. But the at this port 1 and a port 2, this one is about a port 1 we say, this one is about a port 2 we say. Output at this port 2, these two ports here, the waves we are getting, that wave is a out of phase. Okay, that wave will be of a out of phase. And amplitude is a constant. Whatever the signal we are supposed to be propagating, that signal amplitude is a constant, but phase at this particular port 1 and port 2 will be a out of phase. You can say that a out of phase output we are getting. But in the case of H plenty, we'll get the in phase output. Now, if suppose I am saying that a input to the port 3, okay, that we can say that for the port 3, I am saying that a P is the input for the port 3 is applying, or power is incident at a port 3 is a P now. Then the power appears at a port 1 and a port 2. That one port 1 and a port 2 here. That will be what? It is equal to a P by 2. That, so means what we can say that P by 2. So in terms of a power in terms of a dB. So if you consider that, this will be of a 3 dB division of a power occur at port 1 and a port 2. Means we say that input power incident at a port 3, power is divided in a port 1 and a port 2. That power divided at a port 1 and a port 2 here, it is equally now. So that's why we can say that this one, a E plane T is a power splitter, or we can say that it is about a 3 dB splitter. Okay, it is called the 3 dB splitter there. Now, another case is that if we provide, okay, if we have the input at a port 1 or a port, If we say that there is an input at a port 1 or a port 2, then output will be available at a port 1 and a port 2, because we say that port 1 is the input, suppose. Okay, so then the output is to be available at a port 2 or a port 1 now. So in that case, that output will be what? That output will be what? A P by 4 here. And for a port 3, for a port 3, it will be what? It will be of a P by 2 now. So in the case of a input incident power P at a port 1 or a port 2 there, so output will be occurs at a port 2, or we can say that not and, or a port 1, that will be P by 4, and port 3 will be a P by 2. So now with this, we can say that the property of that S matrix there, and again another applications of this E plane T, we say that it is a power divider or a power splitter. So even we can use that E plane T as a power combiner. So in that case, we need to apply the equal input signal at this both port 1 and a port 2. Even this E plane T will be act as a, okay, we can say that it will be act as a power combiner. We have to provide the equal input to the port 1 and a port 2. Then the output signal at this port 3 will be equal here. Okay, the condition is that, so that power applied at a port 1 and a port 2 here, okay, input signal at a port 1 and a port 2, that will be of the same signal, and that signal, okay, that whatever we say it is about the same source we are going to give to the port 1 and port 2, but the phase of that port 1 and a port 2 will be a out of phase. The source will be a out of phase at a port 1 and a port 2. If we apply the input at a port 1 and a port 2 with a amplitude, but it is the out of phase now, then it will combine the power at this port 3. And another thing is that if supposed to be the power applied here, input, we can say that input to the port 1 and a port 2 is the same in a phase as well as amplitude, suppose. Okay, in same phase, suppose we say that same phase, in that case power at a port 3 will be a 0, means output at a port 3 will be 0. The condition is that it will combine a power in both the cases, okay, with the out of phase or in phase. But if it is a in phase output at port 1 and port 2, so then our port 3 output will be 0. If it is out of phase, okay, difference between the port 1 and port 2 there is out of phase, okay, signal, then power will be combined at port 3 here. Okay, so we'll get some output. If it is a equal phase, then power output at a port 3 will be a 0. Means E plane T is act as a power combiner. So now our aim is about to obtain the S matrix here for the E plane T. So what is the S matrix for the E plane T? Generally we say that this, here we can say that a E plane T is about a 3 by 3 matrix. Then we have to draw a S matrix for this E plane T. So now that matrix is nothing but what? S11, S12, S13, S21, S22, S23, S31, S32, and a S33. Now this one is about, we can say that a S matrix for this E plane T now, because E plane T has a three ports there, so that's why that matrix will be a square matrix of a order of a 3 by 3. So that's why here the 3 rows and the 3 columns are there. Now we will find out each and every component values of the S parameter there, and then we'll conclude about that what will be the S matrix for this E plane T in terms of the number here. Okay, for each and every parameter. Now for this purpose we need to consider that a E plane T, that junction, okay, is to be an ideal one, or junction it is to be a reciprocal one. Okay, so that port 3 it is the ideal junction or it is to be a reciprocal one. So that's why the matrix, we can say that it is to be a symmetrical one. So if it is a symmetrical matrix, so then we can say that Sij is equal to Sji. The condition is that I should not be equal to the j here. So that is for the symmetrical property. So in that case, a port 3 is a perfectly matched to the junction. Okay, port 3, it is a perfectly matched. Port 3 is perfectly matched now to the junction. Then in that case, we can say that S33 is equal to 0. Okay, so this component. So this S33 is equal to 0 because this one is a perfectly matched. Then, so we can write here value S33 will be a 0 now. Okay, so next is about another condition is that a port 3, we say that a port 3 is a electrically antisymmetrical. Port 3 is what? Electrically antisymmetrical with respect to port 1 and a 2. Okay, so that port 1 and port 2, that is about electrically antisymmetrical. So that's why we say that we write as per the symmetrical property S11 is equal to S22, and we say that S23 is equal to minus S13. Means we say that input at a port 3, output will be available at a port 2. Input at a port 3, output will be available at a port 1. It has the same amplitude but phase is out of phase. That is about a electrically antisymmetrical. So that's why there is a minus sign here. So now with this, we will rewrite the S matrix. Okay. So the condition is that we have got the condition is about that S11 and S22 here. S11 is equal to S22 and S23 is equal to minus S13. And then from the symmetry property, again we say that Sij is equal to Sji. It is about a symmetrical property. So from this, we can find out that we say that S12 is equal to S21, S13 is equal to S31, then S23 is equal to S32. Now this one is about a symmetrical property. S23 is equal to, from the symmetrical property, S12 is equal to S21, S13 is equal to S31, S23 is equal to S32. Okay, that is through the symmetrical property. Then we will rewrite here the S matrix parameter here. So this one is what? 1 1, S12, S13. Now this term S21, S21, okay, S21 is equal to S12. Okay, that S22, earlier we say that S22 is equal to what for this S11 there. Okay, we say that. Then we can say that S13 here, S23 is equal to what? Minus S13. S31 is equal to S13 and S32. S32 is equal to S23 is equal to minus S13, and this becomes a 0. Now this one is about, we have used or we have applied all the properties here. We have considered all the properties, and through this all this property we have obtained the S matrix here. So S11, S12, S13, S12, S11, S13. Okay, so likewise we have obtained all the properties. Now this particular equation, if you consider here, okay, so from this particular case here, So we can solve that particular S matrix. Then using the unitary property, we say that S matrix complex conjugate of S matrix is equal to identical matrix. That is about I. So already we obtained that S matrix here. We need to find out the complex conjugate of this S matrix into a I matrix. Already we have seen in the H plane T. Then apply that multiplying row 1 and a column 1. Multiplying a row 1 and a column 1. Then we'll get that S11 square plus S12 square plus S13 square is equal to 1. Multiplying row 2 and a column 2 here. Say that row 2 and column 2 there. Then we'll get that S12 square plus S11 or S22. Okay, square is equal to S13 square is equal to 1. Then row 3 and column 3. Row 3 and column 3. We say that S13 square plus S13 square is equal to 1. So now these are about the unitary property. We say that from that unitary property, we'll get that S13 is equal to, this one is about a twice of S13 square equal to 1. S13 is equal to 1 by root 2. Okay. So from this equation, if you solve it here, so we'll get that S13 is equal to 1 by, simply S13 is equal to 1 by root 2. So you just remember that S13 will be a 1 by root 2. Now if you put that, all the values wherever we have 1 by root 2, this term will be 1 by root 2, this term will be 1 by root 2. Only our aim is about to find out these terms here. Okay, S11 and S12 here. Then as we say earlier that S11 is equal to S22. Okay, already we say that. Okay, so like let it be, you just remember that this particular property there. Okay, now we talk about that a zero property. Now instead of that unitary property, we can say that using zero property. So what is the zero property? Zero property is what? Sij into complex conjugate of Sik is equal to 0. Where we can say that J is not equal to K. With that call, whatever we can say that K and J, this will not be equal to, okay, these are not, J is not equal to K here. So multiplying, let's say that multiplying row 3 and a column 1 here. So you can say that S13 to S11, whatever the complex conjugate we have, S13 into S12, whatever the complex conjugate we have, okay, is equal to, okay, now this one is about a equation here. Now earlier equation we obtained that the first equation multiplying row and a column 1, row 1, column 1 and row 2, column 2. And from that equation, if you see that, we'll get that S11 is equal to S22. Earlier even we say that for from the property S11 is equal to S22 we say earlier. And then in third equation we say that S13 is equal to 1 by root 2. Okay, already we decided. Now then from this particular equation here, this equation, if you take a common S13 here, you'll get that S11 minus S12. Okay. So then we can say that S11 minus S12 is equal to 0. This one. Okay, only we say that a complex conjugate of S11 is minus S12 is equal to 0. From this, we say that S11, because that particular port is a match perfectly here, in that case, for the given particular matching condition, so S1 is equal to S212 is equal to S22. Okay, so S11 is equal to S12 is equal to S2. Next, we got the values here. That is about S11, S12, S22 here. If we put that all the values that we got here, S13 value, this one value, in an earlier equation, okay, that equation number 2, that is row 2 and a column 2 there. What is the equation that row 2 and a column 2? That equation is what about S12 square plus S22 square plus S13 square. Now this one is about equation is equal to 1. If you put that, these values, and earlier we obtained that S13 is equal to 1 by root 2. Okay, this one 1 by root 2. Okay, this one. So it will be what? It will be 1 by 2. And S22 is equal to what? We say A S12. S22 is equal to what? A S12. So this S12, okay, and this S12. So 2 S12 here. Or we can say that either we can write in terms of S12 or either we can write in terms of S11. So this particular factor S12, it will be S11 or S22. This will be S22, will be S11. So we can write if supposed to be all these equations in terms of S11. So we'll get that a sorry, twice of S11 square plus 1 2 is equal to 1. So we can solve it, this one here. Okay, so we'll get that S11 is equal to, after solving, we'll get that S11 is equal to 1 by 2. Now, after solving this, we'll get that S11 is equal to 1 by 2. Now, then we got all the values. S11 will be 1 by 2. This will be a 1 by 2 here. Okay. So S12 and S12. S11 is equal to S12, we say. So this will be 1 by 2. This will be a 1 by 2. Okay. Now S11. This one is a 1 by 2. S11 1 by 2. S12 S12 1 by 2 here. These factors we got, and these are was 1 3 is nothing but what? 1 by root 2. Then we will write the S matrix here again. Write the S matrix again here for this particular term. I'll say that again. We'll write the S matrix here for the E plate T here. So this will be what? A 1 by 2, 1 by 2. This will be a 1 by root 2. Then 1 by 2, 1 by 2 minus 1 by, then 1 by root 2, 1 by root 2. Sorry, this one is a minus here. So this one is minus, and this one is. So now that's all about what you can say that we are expecting that answer for the E plane T here. Okay, that is about the S matrix for the E plane T. Now, next we'll talk about that a magic T. Okay, so for the magic T, that magic T is about a four-port network, and that four-port network, how to derive that equation for the magic T, we'll see here. Okay, so that's all E plane T. Next, we talk about that a magic T or a EHT. Just right here, EHT. T means a junction. EHT, or we can say that a magic T. Either EHT or a magic T. No issue here. Why word is that magic T is to be said? Okay, so I'll just draw here the circuit, that diagram of this EHT here component. So it has the E arm as well as the H arm. That's why it is called as EHT. Okay, it has the both the term, that we can say that a E arm as well as the H arm. So that's why it is called as the EHT here. So now, if you see here, the equations for this a magic T, or if you understand what are the properties of this particular magic T, then you are able to see that how to draw this, or how to draw this magic. So I'll just draw a magic T here. One is about your rectangular waveguide. I suppose to first draw a rectangular waveguide component. Okay, now this one is about a rectangular waveguide. Now for this rectangular waveguide, we have a two arms. Okay, we have a two arms. So now what are those two arms? Say that one arm here, that arm is about not what we can say that. Okay, now this one is about our E arm here. Say that supposed to be consider that arm. Okay, now this one is about your E arm. Okay, everything now. Okay, now this one is about our E arm. Now next, we have to draw this H arm here. Okay, we have to draw. So this about a okay. So now this one is about what we can say that okay H arm here. So now if you see the figure here, magic T will be looks like this one is a magic T. So this one about your main arm here. You can say that this one is about a port one, a port two here, main arm here, and this E arm, so it is to be saying a third port here, and that H arm it is to be considered as a fourth port. We can say that this one is about the H arm here, this one is about the E arm here. Arm one, arm two, arm three, sorry, arm three, arm. So it has a fourth port here. Or this junction, we say for this particular junction across this E plane junction or H plane junction. Okay, so means that port is to be matched. It is to be perfectly matched. Then earlier we say that when we provide the input to the port 1 and a port 2, so output will be, because it is about a supposed to be same page, there will get the 0 here. So that's why generally we can say that a E arm, because that if supposed to be input is of our same page, so then it will be 0 output. That's why sometimes some people are saying E arm is a, or we can say that E arm is a called as a difference arm, because same page output will be differentiated, so that's why E arm will be difference arm. And here this H arm, because it is combined one, so it is called as a sum arm. Sum arm and a E arm is a difference arm there. We say that a combiner or a coupler earlier we say. So now what is the symbol of this a this magic? Generally we say that it has a four port. Now symbol is a straightforward. The port one, port two, that is about a main arm, collinear arm we say, port three and one is about a port 4. That is about a symbol for the magic. Now, how we are exciting, how this electric flux lines looking through this particular guide here. So now we can say that this one is about your a port one supposed to be considered. Okay, so now this one is about a port one, this one is about a port two here. Now if we provide, okay, so that is about the input to this particular arm here. So likewise, so we supposed to say that it's about a way of your particular port three here. Okay, so that is about a port. The condition is that we supposed to say that we are getting the output across this particular arm here. Okay, from the given particular port. Okay, if we supposed to say that input from this particular port, so it will be excited here. Likewise, so we supposed to say. Another thing is about what we can say that if we are exciting this port 3 here, we'll get that a output across this that will be a out of phase. Okay, that flux line. So now we talk about that how we are getting the matrix for this S parameter. The condition, as we have seen earlier, that port is to be matched, it is to be perfectly matched, everything, all the conditions are same here. So now, but the condition is that here it has the E arm and the H arm. These are the two different arms, E arm and H arm we have. So then we need to consider that what magic happened for this particular E plenty or H plenty, and why we say that it is about a magic port. So we consider here if supposed to be, we consider that a port 1 and a port 2 here, if we supposed to be give the input, or if we supposed to be consider that a input is given to the port 3 or a port 4. So what happened to this particular junction? Okay, so what happened to this particular junction, that is to be seen here. Now if we apply the input to the port 4 here, that is about, we suppose consider that if there is an input to the port 4 here, then the output will be occur. Okay, output will be available at a port 1 and a port 2, as we have seen earlier. If supposed to be A is the amplitude, so output will be available at port 1 and a port 2, that will be A by under root 2 here. Okay, that is about the amplitude at that particular port. It will be equally divided here. Okay, that particular port here. Same thing, similarly for this port 3 here, output will be equally divided at a port 1 and a, if we give provide the input to the port 3 now, then output will be equally divided to the port 1 and a port 2. Now what about that when we provide the input to the port 3 and well, what about the output at a port? Okay, if we are providing the input to the port 4, what happens to the port 3? That is to be seen. Now here, these are the two junctions. When we apply the input to the any of the arm, E arm or H arm, so output will be available in a collinear arm, but there is no output to the this E arm or H arm. So what is the meaning of this? If I am saying that input is applying to the port 3 here, output will be equally divided into port 1 and a port 2. That is in a out of phase there. But there is no output at this port 4. Same thing. If we provide the input to the port 4 here, output will be equally divided in port 1 and a port 2 with a phase, but there is no output at a port 3. Now this one is a magic. It is to be used, okay, and most of the cases to define, so or to derive the S matrix. Okay. So we consider that output generally we say that it is divided. If supposed to be we are providing the any of the arm here, it is equally divided. If it is in terms of a power or it is in terms of amplitude, it is equally divided. Means E arm, okay, E arm, if we are providing the input, so output will be equally divided there. Okay, so if we supposed to provide the input to the H arm there, so output will be equally divided to the 1 and a 2. So we say that a input supposed to be to this particular collinear arm, either port 1 or a port 2. Now suppose I am saying a signal into this particular coplanar arm or a collinear arm we have, then output will be equally divided into port 3 and a port 4. So we say that a output in terms of a power, we say that P by 2 here, or if we can supposed to be consider that power input here, suppose P here, so output will be equally divided by P by 2, P by 2. Okay, but no output at this port 2. Okay, so no output at this particular port 2. Only this port is the input, output will be available here. Then if that input is given to this H arm here, then output is equally available to this coplanar arm, that is port 1 and a port 2 here. Okay, but that output will be of a same phase there. Okay, that output will be of a same phase there. So then port 3 input output will be equally divided port 1 and port 2. It is about the same phase. Okay. If we provide the signal to this port 1 and a port 2 here, okay, same signal providing to the port 1 and a port 2, then what happens? So at this E plane, because we say that E arm is the difference arm, so output at this E arm is the difference between that port 1 and a port 2. Okay. Similarly, if we supposed to be input given to the port 1 and port 2 here, so output will be sum here. Okay, it is about a summation takes place and a difference takes place at this particular arm there. So what is the S matrix for this magic T? So S matrix for the magic T, because since it has a 4 arm here, so that S matrix will be of a square matrix of an order of a 4 by 4 here. Order of a 4 by 4. So we will find out the S matrix for this magic T, and so that's why we supposed to be consider that the EHT here, and that matrix for this S4, that magic T will be what? Of a 4 by 4 matrix. That is about what you can say that S11, S12, S13, sorry, S14, S21, S22, S23, S24, okay, then S31, S32, S33, S34, then S41, S42, S43, and a S4. Now this one is about a S matrix for the magic T. Now, so we need to consider that how to derive all these component of a magic T. Okay, S matrix for this magic T. So we'll see, okay, this derivations of this magic T. Okay, thank you here.